Good day everyone, we will be discussing the factorial experiment in CRD or the completely randomized design on the laboratory exercise number 9. Now, what is the factorial experiment in CRD or the completely randomized design? Now, each level of a factor must appear in combination with all levels of the other factor. Factorial arrangements allow us to study the interaction between two or more factors. Now, for a completely randomized design or CRD is one where the treatments are assigned completely at random so that each experimental unit has the same chance of receiving any one treatment. For CRD, any difference among experimental units receiving the same treatments is considered as experimental error. Now, during the discussion, we will be finding out if there are significant differences on the main effect and the interaction effect. And also, we will be computing for the CV or the coefficient of variation and illustrate the possible layout of the experiment. And also, we will be showing the computations and transfer the result and complete the ANOVA table. Now, the data shown are the average milk yields obtained from cows for a 4 weeks period as affected by 4 different feed treatment and 3 levels of vitamins. Now, to get the amount for the factor A, in the table we have 4 that indicates the 4 weeks period affected by 4 different feed treatments. Now, for the factor B, we have 3 as indicates by the 3 levels of vitamins. Now, to get the number of replicates, all we need to do is we are just going to get the number of experimental units in a treatment, which is in here is 3. Now, to solve for treatment, all we need to do is to multiply the factor A and factor B. So now, for the factor A, we have 4 and multiplied to the factor B, which is 3. And as the result, we can get the amount of 12 as the number of treatment. And now to get the number of observation, which is indicates here is 12.
Okay, so the next slide is we're going to get the total, subtotal, and the grand total. Okay, so the data below are the average milk yields obtained from cows for a 4-week period as affected by 4 different feed treatment and 3 levels of vitamins. So we have here 4 different feed treatment, which is the feed treatment A1, A2, A3, and A4, and 3 levels of vitamins, which is the BA, B2, and B3. Okay, so how are we going to get the total? So simply add the numbers inside the treatment. Okay, so example, the feed treatment A1, we have here the BA. So inside that is the 30, 20, and 26, which is also inside each replication. The replication 1, replication 2, and replication 3. So when you add what's inside replication 1, replication 2, replication 3, which is 30 plus 20 plus 26 is equals to 76. Okay, just repeat the process for B2 and B3. So that is how are you going to compute for the total. The same also sa feed treatment A2 hangtod sa feed treatment A4. Okay, so let's go to the solving for the subtotal. Okay, so example is in the feed treatment A1. So just simply add all the numbers inside the replication. So example is the replication 2. So inside the replication 2 is 20 plus 25 plus 40. So if you're going to add them all, that is 85. So just add all the numbers in the replication. The same also to the different feed treatment. Okay, so let's go to the grand total. So how are you going to solve for the grand total? Just add all the numbers nga imong nakuha from the total. Okay, so from feed treatment A1 total, you're going to add that hantod sa feed treatment A4. So 76 plus 71 plus 105 plus 82 plus 91 plus 114 plus 73 plus 88 plus 106 plus 93 plus 94 plus 112 is equals to 1,105. Okay, so just remember how to solve the grand total, the total, and subtotal. Okay, so the total is the summation of kanang tanan nga each treatment. Okay, so kung pila ka buok treatment, imo lang yung sulod sa treatment, imo lang i-add mo na imong total. Dayon ang subtotal is a replication pod siya. So patindog mao pod ang imuhang buhaton i-add lang tanan. Dayon sa grand total is mao na siya ang katong tanan nga imong na-add didto sa imuhang total. So i-add lang nimo siya tanan mo na din imong grand total. So diri is atong grand total is 1,705. So we are here now at the randomization and layout. So how are we going to randomize and lay out this problem? First, we need to identify what is the randomization scheme na atong gamiton. So in this problem, we are going to use the table of random numbers. So from the table of random numbers, we're going to pick 36 ka random numbers. So how are we going to identify the 36 random numbers? Dili ta mahimong bias o dili ta mag-cheat. So you can close your eyes, then pick. In my case, I landed with number 14620. But since we are going to use the last three digit only, so started with 620, followed by 724, and ended to 453, which is the last number, or the 36 ka nga random number. Okay, so unsa din natong buhaton next? Mag-sequence ta, number na nato siya og 1 to 36, dayon mag-rank as a whole ta. Okay, so unsa ang pinaka-una, ang pinakagamay nga number? Ang pinakagamay nga numbers is ang 040, so mo na tong number 1, rank 1. Then followed by 069, mo na tong rank 2. Imo lang siyang kuanon kung unsa ang pinakagamay hantod sa pinakadako. So, ang pinakadako is ang 953. Muna to ang rank number 36. So after you identify your random numbers nga imong gamiton, mo jump na ta dito sa ato ang experimental units design. So as you can see here in the table, we have here 12 treatments and 3 replications. So yun sa ko na siya pag-arrange. Ngano arrange ko ingon ana nga nawong. Okay, so mo kwarta dito sa ato ang first step, nag-randomize tag number. So sa ato ang rank dito, kadto ra tong sundon. Okay, so in this problem, pinakauna diri sa rank is ang 25. So ako lang siyang gi-follow. You just have to follow that one. Hantod nga moabot ka sa pinaka-last. So ang pinaka-last diri is ang 14. Rank number 14. Okay? So i-fill in lang nimo na siya dira. So kana nga table, kaning nga table is muna siya tong possible randomization result. Una ta sa ato ang possible layout. So how did I came up with this possible layout? So ang first is depende nimo kung unsa imong gamiton, ascending ba or descending order. So kani nga problem is I did use the gikan sa gamay padulong sa pinakadako. Okay, so dito ta sa rank maglantaw. Okay, so ang 1 diri ka maglantaw sa possible randomization result. So ang 1 diri is na located in treatment 4 replication 1. So muna mong ibutang dira sa box number 1, and then followed by number 2, which is located in treatment 6 replication 3. So mo pwede mong ibutang, and so on and so forth hantod makaabot ka until you reach the end, which is the 36. And 36 is located in treatment 6 replication 1.
For degrees of freedom, we have treatment AB minus 1 is equal to 4 times 3 minus 1, total of 11. For factor A, we have A minus 1 equals to 4 minus 1, a total of 3. factor b, we have b minus 1 equals to 3 minus 1, total of 2. We have a times b equal to a minus 1 times b minus 1 equal to 3 times 2, a total of 6. For an error, we have ab times r minus 1 equals to 12 times 3 minus 1, a total of 6. And for our total, we have abr minus 1 equal to 4 times 3 times 3 minus 1, total of 35. And for problem 1, L total for AB. For the column of F1, we have 76, 71, 5, total of 252. For F2, we have 82, 91, 114, total of 287. For F3, we have 73, 88, 106, total of 267. For F4, we have 93, 94, 112, total of 299. For our row of B1, we have 76, 82, 73, 93, total of 324. For B2, 71, 91, 88, 94, 344. For B3, we have 105, 140, 106, 112, 437, 437. The grand total is 1,105.
Computation for sum of squares. So in number 2, the formula is total of SS is equal to the summation of x squared minus CF. So equal to 30 squared plus 26 squared plus 30 squared plus up to 38 squared. Then minus 2, 33914.36111 is equal to 35071 minus 33917.36111 equal 1153.63889 or 1153.64. So in number 3, the formula is TRSS is equal to the summation of AB squared divided by R minus CF. So equals 76 squared plus 71 squared plus 105 squared plus up to 122 squared. Then divided by 3 minus 33917.36111. Then equal to 104181 divided by 3 minus 33917.36111. Then equal to 809.63889 or 809.64. So in number 4, the formula is ASS is equal to the summation of A squared divided by BR minus CF equals 252 squared plus 287 squared plus 267 squared plus 299 squared divided by 3 times 3 minus 33917.36111. Then it equal to 306563 divided by 9 minus 33917.36111. Then it equal to 145.1944465 or 145.19. So in number 5, the formula is ASS is equal to the summation of B squared divided by ER minus CF. So equals to 324 squared plus 344 squared plus 437 squared divided by 4 times 3 minus 33917.36111 equals 414281 divided by 12 minus 33917.36111 equal to 606.0555567 or 606.06. So in number 6, the formula is A times B SS is equal to TR SS minus A SS minus B SS equal to 809.63889 minus 145.194456 minus 606.055567 then equal to 58.388887 or 58.39. In number 7, the formula is ESS is equal to TSS minus TR SS is equal to 1153.63889.63889 equal to 344. Computation for men of squares. So in number 8, the formula is MSA is equal to ASS divided by ADF equals 145.1944456 divided by 3. So it equal to 48.39814853. In number 9, the formula is MSB is equal to BSS divided by BDF equal 606.0555567 divided by 2 to equal to 303.0277784 or 303.03. In number 11, the formula is MSE equal to ESS divided by EDF equals 344 divided by 24 is equal to 14.333333 or 14.33. In number 12, the formula is MSE is equal to ESS divided by EDF is equal to 344 divided by 24 then equal to 14333333 or 1433.
To proceed, we will now solve for the computed f value of factor A, factor B, and the interaction. To get the computed value of factor A, we will simply divide the A mean square with the error mean square. We have already computed for these values, so for the A mean square, we have 47.39814453 and then divide that with the error mean square, that is 14.333333, and we will be getting the value of 3.376615,015. And if we'll round that up by the hundreds, the final answer would be 3.38. To get the computed f value of factor B this time, we will be using factor B's mean square and divide that with the error mean square. So that would be the mean square of factor B 303.02777784 divided by the error mean square, and we'll get 21.1414729. And finally, for the computed f value of the interaction, we will be using the value of the interaction's mean square, that is 9.73148128 by the error mean square of 14.333, and the answer would be 0.6789405548. Now, to complete our ANOVA table, we will be finding for the tabular F value of the main effects A and B and the interaction effect. First, let's locate for factor A's tabular F value. In the F table, you can see numbers in the far left and on the top. In the far left, we will be searching for the number corresponding to our error DF. Earlier, we've solved for the error DF and found that it is 24. So in the table in the far left, we will be searching for the number 24. After that, for the numbers above the table, the number we will be searching for is factor A's DF, which is 3. So below 3 and along number 24, we have now the tabular F value of factor A, which is 3.0145% and 4.7241%. For factor B, we will just follow from how we got the tabular F value of factor A. In the far left, we'll search for the value of the error DF, but this time for the top number, we will be using the value we got from factor B's DF, which is 2. So below 2 and along 24, we have the values 3.4045% and 5.6141%. And for the interaction effect, we'll still use the value of 24, and rather than the DF of factor A and factor B, we'll use the AXB DF, which is 6. So below 6 and along 24, of the values 2.5145% and 3.6741%. And that is all we need to complete the ANOVA table. These values can then be used in making our conclusion later. Before making our conclusion, we'll be computing for the coefficient of variation. This will be the last computation for this problem. To get the value of the coefficient of variation, we will divide the square root of the error mean square by the treatment mean and multiply that by 100. After computing for the ANOVA table, we can now complete the table. We have 11 for the treatment DF, 3 for ADF, 2 for BDF, 6 for the interaction DF, 24 for the error DF, and 35 for the total DF. We also have the computing values of the sum of squares, mean of squares, the computed F values, and we earlier located for the tabular F value. After getting the computed F value and tabular F value, we can now make our decision. To finding out the conclusion on the factor A, we will just compare the factor A's computed F value with its tabular F value. As you've seen in the ANOVA table, the computed F value is greater than the tabular F value at 5% level of significance, but is less than the tabular F value at 1% level of significance. Therefore, the conclusion would be the computed F value is greater than the tabular F value at the 5% level of significance, but less than the tabular F value at 1%. Therefore, the treatment difference is significant, designated by 1 asterisk. For factor B, similar from how we've made our conclusion with factor A, we will just compare factor B's computed F value with its tabular F value. In the ANOVA, we can see that factor B's computed F value is greater than the tabular F value at 1% level of significance. Therefore, our conclusion would be the computed F value is greater than the tabular F value at 1% level of significance. Therefore, the treatment difference is highly significant, designated by double asterisk. Lastly, we will be finding out the treatment difference of the interaction effect. The computed F value of the interaction, that is AXB, compared to its tabular F value is less than the tabular F value at 5% level of significance. Therefore, the conclusion would be the computed F value is less than the tabular F value of the 5% level of significance. Therefore, the treatment difference is non-significant, designated by NS. Those would be our conclusions. Now let us review if the required questions earlier were answered. To finding out the significant differences on the main effects in the interaction effect, we have compared the computed F value with its corresponding tabular F value. Note that the main effects that this question is referring to is the factor A and factor B. If you can remember, the significant difference in our main effect factor A is significant, while our main effect factor B is highly significant. For the interaction effect, that would be AXB, its significant difference is non-significant. We also already solved for the coefficient of variation, where we divided the square root of error mean squared to the treatment mean and multiplied it by 100, and we got 12.3342,857. We already have given the possible layout of the experiment, and it is just similar to the layout on the normal CRD. We have also computed and completed for the ANOVA table. So that would be all for our report for the factorial experiment in CRD. Thank you very much for your attention.